Hello friends, how to build and monetize generative AI plugins using PostgreSQL pgvector and Spring AI. That was the title of one of my conference talks, and I have already given this session at several events. There is one interesting feedback that I kept receiving from those who managed to join those events. Some of the folks stopped by and said, "Dennis, do you have an online version of this session? Because we found this talk inspiring and insightful, and it would be nice if we could share it with our colleagues and friends." So today I decided to follow that piece of advice and create an online version of that session. So we are going to create a ChatGPT plugin from scratch, and that plugin will augment the behavior of the ChatGPT. And our implementation is going to be based on Spring AI, and we are going to use Postgres as a vector database. So let's not waste a minute and do a deep dive. All right, my friends, and we are starting with so familiar ChatGPT interface. That's right, I headed to the chat at OpenAI.com, and this is the tool that many of us use daily. However, apart from having that conversation with the AI, what we also can do these days, you can explore and use various plugins or GPTs that are available on the OpenAI marketplace. To get to that marketplace, you need to click on this Explore GPTs button, and then you will find a bunch of different plugins that were created by an AI community. You can see featured plugins, something that is trending, and there are different categories, that's for sure. There is one common theme across all of those plugins. All those plugins augment the behavior of one of the GPT models. So the GPT model, let it be GPT 3.5 or GPT 4, is going to be the core component of every plugin, because still when you use any plugin you are interacting with the ChatGPT, but then the behavior of the ChatGPT and the knowledge base of the ChatGPT will be augmented by the data and by the actions that are provided by a specific plugin. So today, in the end of this video, we will launch our own plugin, and shortly you will see what that plugin is going to be doing. Okay, so let's move forward. The first step, our flow for today is going to be looking as follows. So let's quickly write down the agenda. The plugin needs to interact to something or to someone, and that something or someone is going to be our application backend. We will start with the movie recommendations service. We already have a skeleton, and we would need to complete an implementation. This movie recommendation service is a GenAI application. It will be taking the user questions and prompts in plain English, and then it will be providing those users with various movies recommendations. And throughout this video, we will be testing and creating two implementations for this GenAI app. The first one is going to be using the ChatClient interface of Spring AI. And when you use this interface, effectively you are going to be interacting with an LLM such as GPT-4 directly. How it will work? So the app will take this user prompt, and this user prompt is going to be sent to the GPT-4 model, which is our LLM. So this is actually the way how you interact with the ChatGPT over that web interface, but also you can interact with GPT-4 model programmatically. After that, we will switch to the second implementation of this application for two reasons. The first reason is that the ChatClient based implementation is going to be a little bit slow. Why? Because this prompt needs to be sent to the GPT-4 model, and it will just take time to come up with those recommendations. So it's just not that fast. And second reason is that the data, the information that is going to be returned by the GPT-4 model might not be up to date, because all the data, all those movies might be relevant for some of the prompts, but they might be completely wrong for some other prompts that are asking, let's say, for the latest movies starring Matthew McConaughey. That's why the second implementation is going to be using our own data that stores information about movies, and the data is going to be located in Postgres. Once you have your data in your own database, then you can provide users with unique movies recommendations that are related to your business. And second, those recommendations are going to be provided much faster. That's why the second implementation is going to be using the EmbeddingClient of Spring AI. The workflow is going to be looking as follows. So the application again is going to be using the user prompt. Then we will use the embedding client to translate this using prompt to the prompt embedding. And after that, we will be performing the vector similarity search over Postgres. So once this movie recommendation service is going to be ready, then we will move forward and create our plugin. What the plugin is going to be doing? It's going to be a fully autonomous AI agent. If to be more specific, it's going to be a movie critique. That agent will be interacting with our movie recommendation service. We are going to use ChatGPT as the user interface, and the ChatGPT is going to be using our plugin. That plugin is going to be interacting with our application backend to perform various tasks, such as it will be able to provide movie recommendations, and also it will be able to perform tasks for us, because this is the fully autonomous agents. For instance, if you find that some of the movies are interesting, that the agent will add those movies to your watch list. If you have already watched any of the movies, then the agent will be able to remove those movies from your library. Okay, so it's going to be actionable. It's going to manage our watch list. Sounds like a good plan? So that's why let's drill down to the implementation. My project, and I will give you a link to this project, is already on my local machine. It's called OpenAI GPT plugin using Postgres pgvector. And presently it has the application backend and the application frontend. As for the backend, it's Java. I'm using Spring Boot, and we will be using SpringAI to bring that AI related capabilities to the app. And as for the frontend, it's written on React. Now, let's start this application and see what's going to be happening. I will go to the backend, and then in the backend, I am performing this familiar command for those who are coding in Java, Maven Spring Boot run. Okay, it said that I'm connected. So far, so good. Also, let me start the application frontend. We are going to the frontend directory and performing npm start. Excellent. Now I can copy this address and I can go to the application backend. You can see our Yuga Plus. This is our movie recommendation service. At least I took care of the security. You need to sign in. Now let's make this font size a little bit smaller. To the left you have these movies, that's the user watch list, the movie catalog that you want to watch. And then to the right you have this search area where you can ask for different recommendations, and then the AI is supposed to help you. How about this prompt? Long ago in the galaxy far, far away. And I guess that's almost all of what the list of the movies should be. You click in the search and it said, uh-oh, not implemented. Which means that we have some job to do right before we even start thinking about our GPT plugin. Let's go to the implementation and the movie controller. And this movie controller listens on the following REST API endpoint. When you take a look here, this is the search method, and this search method is executed whenever you click this search button on the application UI. So presently, if you take a look at the implementation, you will see this not implemented method, and their method returns the following error. Also, we are getting this prompt. You can pass the UI also passes these parameters, but we will be ignoring these two today. What I want to do first, as you remember, we want to implement the ChatClient based version of the application that will be taking this user prompt, and then we'll be performing the search using the GPT-4 model. I will be using the ChatClient. I have already imported the SpringAI library, edited to my project. So this is the ChatClient. And next, let's pass this ChatClient to the constructor. Initializing it, done. What's going to be the implementation? The implementation is very straightforward. I'm not going to explain you all the nuances and foundational knowledge on how that works, but what you need to know. First, we will create the system message, and the system message will be a sort of an instruction to the GPT-4 model what it expects to do for us. And this system message is not visible to the user. This system message is going to be added to our prompt to the LLM with every request. Every time someone executed this search method, we are going to create the system prompt, we are going to add the user prompt to the request, and we will send this request to OpenAI. How does the system prompt look like for this application? I will not be able to type it from scratch. So that's why I will just go ahead, my friends, and copy it here. Now let me change something in here, and we are pasting it. So this is the system message. It said that you're a world famous movie critic who can easily come up with movie recommendations, suggest at least 3 movies based on the user preferences, and also my application backend expects a JSON object as an output. You can see these movies that are added to the user's catalog, and those movies are displayed from a JSON that is sent from the application backend. That's why I'm telling to the LLM, please send back an array of JSON objects in the following format. I want to know the title, I want to know the overview, vote average, and the release date of the movie. And just in case, I'm telling the LLM that please don't add anything else to the response. I need only the JSON. Okay, so this is the system message. And the next step is we need to create the prompt message, and the prompt message is going to be a list of messages where we have our system message and we have the user message. And the user message is what you pass from that application UI. Finally, now let's use this ChatClient interface, and Copilot doesn't know the up-to-date specification. We need to call the call method, passing this prompt. Once we get this chat response, I know that we want to convert this response to JSON and return it back to the application. I'm going to use the JSON builder library, and first I need to specify the date format. Why do I want to specify the date format? Because if we take a look at the system prompt, I'm asking to return the movie release date, and I'm asking it in the following format. That's why when this JSON is going to be parsed by the JSON builder library, the format is as follows. After that, yes, we are getting this JSON object, and then we are getting a list of movies from our response. But the response, I think the response is wrong. We need to get result, we need to get output, and then we are getting content. And then, now, the list is not going to work yet, Copilot, come on. We need to return the array movies. And we are doing the same. Yep. And finally, this is our complete implementation. Let's go and change the response. Yes, we suppose that it's going to be success. Then we are telling that we are returning the HTTP 200 response. Okay. And finally, no any messages need to be added to the response. We just need to return a list of movies. Nice. This is our complete implementation. So generally what happens, let's quickly recap. We are creating this system message where we are instructing the LLM what it expects to do. And we are asking to provide a list of movies in this as a JSON object. It's an array of JSONs. We want to get at least 3 movies. Then we are constructing this prompt object, and the prompt object takes the system message and the user prompt. And finally, we are performing this network call to the LLM. And then once the LLM responds, we will take this response and try to convert it to the movies, and those movies are going to be returned to our application. Okay, so now let's go to the backend. We need to restart it. Done. Okay. Going back to the application. Yeah, we need to sign in once again because the session was killed as long as we restarted the backend. But now when you perform the search, something is happening. And generally what's happening right now, we send that request to the OpenAI APIs, And it took around, let's say, 8 or 10 seconds to provide the following recommendations. And look, the recommendations are relevant. This corresponds to what I was looking for. However, what I don't like about this implementation, first, it takes usually like 8, 10 or like 15 seconds or more to get this data. Why? Because you are performing the search over that neural network, over the LLM data, and this is quite expensive operation. And come on, these days there are so many folks who use GPT-4 model in parallel. So that's the bottleneck. And second, I don't find anything unique about this, in a sense that, yeah, some of this data might be publicly available, some of this data might be not up to date, but I have my own data. Imagine that I work for some streaming company or some movie company. It can be Netflix, and can be Paramount Plus, Peacock, or whatever you like. And those companies usually have all the private data that is stored in their databases. That's why my second step would be to provide the second implementation of this application. That implementation is going to be using the embedding client of SpringEye. We again will be taking this user prompt, but then we will be using the embedding client to generate an embedding for that prompt, and then we will perform the vector similarity search over our movies related data that is stored in Postgres. Okay, now let's take a look at our database. I have Postgres running on my local machine. It's here. And I'm also using the pgvector extension. This is the extension that enables the AI-related capabilities in Postgres. This is the foundational extension for GenAI apps with Postgres. Now, let's connect to my database using PSQL. And as long as it runs on Docker, I can easily connect it from my host operating system. Once we are in, this is my movie table. If you take a look at the structure of the movie table, you will find the following columns. There are many columns. Certainly every movie has an ID, the movie has the title, but also every movie has an overview. And that overview is a short description of the movie. And what I did in advance before this video, I took every overview for every movie, and then I used an OpenAI embedding model to generate an embedding for every overview, and I wrote every embedding back to the database. And those embeddings that correspond to the overviews are stored in the overview vector column in my database. I was using TextADA002 model of OpenAI, and that model generates 1536 dimensional vectors. And this vector data type is enabled by the Postgres pgvector extension. Where can you find all those settings in your application? If I jump back to my application, in the application properties file of SpringEye, you will find these settings. For instance, SpringEye OpenAI ChatClient model GPT-4, that one was used for the current implementation that uses the ChatClient API. We were using the GPT-4 model, but also for our embedding client, we will be using text embedding ADA002. So all those user prompts that are going to be passed from our user interface, they will be converted to a vectorized representation using the following model. And the same model, once again, was used to generate these overview vectors for the movie overviews. If you want to take a look how the data looks like, we can easily do this. Select ID, title, overview, and overview vector from movie, and let's just get one of them. If you scroll, not the best representation, let's do X on. And now you have that embedding, the very long, and somewhere at the top you can see that's the movie ID, that's the movie title, that's the description, and this is the embedding that corresponds to the following description. So we did this, and you can easily do this as well for your own data. You just need to pick the most relevant columns that will be used for the vector similarity search. Now, let's go to our movie controller and change the implementation. Unfortunately, my friends, I need to get rid of the current implementation. And now our next implementation is going to be talking to Postgres. It's going to be querying the data that is stored in our database. For that, let me add the embedding client to the application. No, we no longer need the chat client, the embedding client, passing it to the constructor. Okay, done. And going back to the search method implementation, we are getting this user prompt. And as I said, the first step would be to take this text representation of the prompt and convert it to a vectorized version. You use EmbeddingClient, and then you have this method called embed. And that embed method takes our user prompt, and what it gets in return, it returns you a list of doubles. Generally, this is an array of floating point numbers. And after that, we need to perform a vector similarity search over our Postgres database. I know that SpringEI has special abstractions that let you interact with the database directly, but I am that SQL guy and I like to write SQL requests from scratch. That's why today I will show you how you can use the Postgres pgvector extension directly in SQL. But feel free to use the primitives that are provided by the SpringEI framework. As long as I want to write my SQL from scratch, I will be using ChatGPT and the ChatGPT has the SQL method where you need to write your SQL request. We are going to select what? We need to know this movie ID, movie title, movie overview, and then we want to know the vote average, how people like that movie or dislike it, and the release date. Okay. So where you find this information, if you go to this movie object, yeah, that's the data. We are querying this data from where? From the movie table. And then what data do we want? We want to get only those movies that are relevant for the user prompt. We need to perform the vector similarity search. First step, you need to calculate the distance between the user prompt and the movie overviews. It's easy to do. There are several ways how you can calculate the distance. We have this overview vector column, and we will be using this operator. And this operator is the cosine distance. The cosine distance is an angle between two vectors, between a vector over movie overview and your user prompt. Also, we don't want to have any injections, so that's why we are passing the user prompt as an argument. And we are also converting this to the vector data type. Once you calculate the distance, okay, then you generally can return all those movies that are the closest, let's say from the angle standpoint, to your user prompt. But usually when you do this vector similarity search, you compare their similarity. And the similarity is calculated this way. You just need to take this distance that you calculated and subtract it from 1. And that's how you're getting the similarity. The similarity is the value in the range from 0 to 1. The closer the similarity to 1, the more relevant a movie is for your user prompt. I would just say that, right, return all the movies that are at least 70% close to the user prompt. Nice. Next, we're definitely going to get more than 3. And I want to order by distance as well, probably by similarity. Let's copy this. Order by similarity. And yeah, we want to do this descending first because those that are the closest needs to be returned first. Now, yeah, cool. Once we constructed this request, we need to pass this user prompt parameter. This is our user embedding. I will pass it as a string. Probably that's not the best way to pass it. If you go in production, figure what's the easiest and the best way to pass the list of doubles to Postgres as a vector data type. I'm just taking this shortcut right now. And next, we want to query this method. And when we query, we want to get the movies class as a list, right? And then we are getting these movies back. Finally, let's go to our response and everything back. Okay, so this is our complete implementation. Let's recap. We will be sending this request, different user prompts from the UI. Then we will be taking this prompt. We will be using the EmbeddingClient of SpringEI to generate a vectorized representation for the prompt. And then we will be performing the vector similarity search over the data that is stored in Postgres. In particular, we will be performing the search over the overview vector. We will be searching for the movies that are most relevant for the provided user prompt, and then we will be returning 3 of them. After that, we will be responding to our application. Looks good. Hopefully there are no any bugs. We will figure this out. I need to restart my backend one more time. Fingers crossed. Excellent. Okay. Jumping back. Yes, we need to sign in one more time. Executing this request once again. Oh, yeah, there seems to be some exception. Let's see what's happened here. Yeah, I've got some syntax error. Let's double check. Yeah, this one. From movie where? Yeah, come on, Dennis, come on. Let's restart. Hopefully this time everything is gonna be neat and clean. But you never know, right? Alright, let's restart. Come on, something else. There's so many bugs in my implementation. Just one more typo. It should be release date, folks. Sorry about that. But I guess that's gonna be the last restart, I promise you. Excellent. And now we've got the list of these movies. How do you like it? And take a look at the speed. It literally takes just less than a second. Refreshing, and the data is here. Because the data is stored in your database and you're performing the vector similarity search over your data. And the data is accurate. So for instance, let's say that I like this movie. What also this application does, you can add a movie to your catalog. I know, this dark crystal. It appears to this catalog, and if you don't like anything, you can always take it out. So this is what the application does. Now, what are we going to do next? Let's finally get to the plugin, because I guess that many of you wanted to see how to create plugin, but I think that it's worthwhile the time we spent on building this application backend, because that plugin is going to be interacting with the following version of the backend, and you will see what type of stuff you can create. Let's go back to the chat.openai.com. The next step when you want to build your own plugin, you click this create button. And in the configuration, you certainly can come up with some name. You need to provide some description and instructions to the LLM, such as GPT-4, and those instructions serve as that system message that we used in our ChatClient based implementation. So still, the LLM needs to know what this plugin is all about, what it's expected to do, and how the LLM can benefit this plugin. It's all text to have some conversational starters for the users. You can upload your private knowledge. For instance, if you have some PDF files or some other documents, you can upload those files here, and the ChatGPT will be able to learn that information and do something unique. But today, I'm gonna be creating another plugin. We created this backend, and I want this plugin to interact with my application backend. For that, you have this actions menu, and you can create new action. When you click this create new action, you will find some schema. So generally speaking, OpenAI uses the Open API specification to interact with your third-party services. And that specification is quite easy to follow. It's standard. You just need to find a way how to explain your existing API endpoints of the application, and then the LLM, the ChatGPT, will be able to use the schema to search through the data that is stored in your database and to perform various actions for you. Now, what that specification needs? It needs to have those API endpoints. And all those API endpoints are already coded and available as part of our application backend. For instance, we already use that UI for the movie recommendation service, but you can use HTTPI or curl or any other tool to send those HTTP requests to your endpoint directly. For instance, we listen on the following port number on the local host, and if you execute the searcher API passing the prompt, then guess what? You are going to get a list of movie recommendations. This is exactly what we saw on the application UI. Also, the movie controller is not the only one that has those API endpoints. We also have the user library controller. You can load their current user library, their watch list. Then you can add new movies to the catalog, you can remove the movies catalog, so you can perform various manipulations. And those are also the APIs that are available through REST, and they will be available to the ChatGPT if we specify them using the specification. As an example, let's try out this call. I want to get their library, the watch list for one of the users, and I'm using this XAPI key header. I don't support multiple users right now for the plugin. That's why when anybody connects to the backend using the following value of the header, then we will be working with the first user that is stored in the database. So we are getting the list, and we are getting the following movie that is in the user catalog. If you jump back to the UI, and for instance, you want to get this movie to the catalog, it will appear here. And if you execute this request one more time, now you can see that we have 2 movies in the catalog. So this is the first step. So we have this application. The application obviously has those API endpoints. But now we'll need to deploy this application somewhere, because the ChatGPT, when it will be interacting to our plugin, to our backend, it needs to connect to something that runs in the internet. So what I did, I just deployed my application on Heroku. You can deploy it on Heroku, you can deploy it whenever you like. If you decide to do this on Heroku, I will share this repository with you. And in this repository, I have these instructions that basically explain you how to deploy this application step by step in Heroku. So you will be able to find it. But now let me just show you my Heroku implementation. That's my OpenAI GPT plugin backend, the same application that performs the vector similarity search over the Postgres. As for the settings, you can see that you can connect to this application on the following domain. That's one of the requirements. If you want ChatGPT plugin to talk to your third-party service, that service needs to be deployed and available on some public domain, and the connection must be secured. If your domain is not public, or if you are using non-certified certificate, then the ChatGPT will keep ignoring your plugin. So, but everything looks fine, and we can test, let's say, if this application responds. How do we test? Let's just modify these API requests. Instead of sending these calls to the local version of the app, we will send this request to our app that is deployed on Heroku. And we are getting these recommendations. Finally, at least the application is up and running. Also, just to make sure that the following API endpoint responds, I want to get the user catalog. Okay, we are getting it. Now, let's do this. I want to open a connection to Heroku logs. I won't be looking at the logs, just to make sure that when ChatGPT does anything for us, it interacts with our application instance backend. And also, I want to check the status in the database, because sometimes this AI agent will be changing the data that is stored in our database. I will connect to my database instance, and the database instance is deployed also in the cloud. As for the database, I'm using Yugabyte. YugabyteDB is a Postgres compatible database. It's built on Postgres. It's a distributed version of Postgres. Here is the UI interface, and the reason for selecting YugabyteDB for my production grade deployment is this is distributed. And those embeddings that are generated and stored in my application, they're quite large objects. For instance, for this application, I use this text88002 model that generates 1536 dimensional vectors. And if you start, let's say, storing at least 10 million records in your database, then you would need to allocate 57 gigabytes of memory and disk just for this embeddings. And so generally, if your plugin becomes successful, then you can easily run out of available memory and storage space. Plus, all those similarity searches, even if you use exact similarity search or approximate nearest neighbor search, still it's a compute intensive operation. But when you run distributed Postgres, such as Yuga by DB, then you will be able to use unbound number of CPUs and GPUs. For instance, that you need more CPUs and GPUs, you just add another database machine to your cluster. So here I have these tables, everything is already created, it's the same, you don't need to change your application source code, you just need to provide a different database connection endpoint. And as long as Yuga by DB is distributed Postgres, it also supports Postgres pgvector. Let's query the pg extension. And here is in the pg extension, you will find the Postgres pgvector, which is already installed on my Yuga by DB instance. What I will be doing today here, I will be looking at the movies catalog for our users, and we'll be executing this query from time to time. So that's our application backend. This application backend is connected to Yuga by DB distributed Postgres. And now we need to create this specification and provide this specification here in the plugin settings. Okay, we are not going to write this specification from scratch. You will find it in the repository. But generally, it's very straightforward. You do it once and you forget about it. And by the way, there are several plugins that are available on ChatGPT that will help you to create the specification. So it's extremely simple. So this specification, what it says, we are using this OpenAI version. Then that's just the description of our backend. Our server, our backend listens on the following IP address, this domain, and we have already tested this domain. It responds. It said that our service provides the following path, the following API endpoints. First, you can search for movie recommendations, the operation ID, the summary, and the description. And this description, why you should provide a very well-written description, because the ChatGPT, the GPT model, will be learning on the capabilities and on the purpose of every API endpoint by looking at your description, okay? So you don't need to provide extra information in your system message, in your instruction, as you will see. You just need to make sure that you document your API endpoints properly, and that's it. Just create a good documentation. And then you're saying, like, these are the parameters. Certainly you can pass the user prompt and this prompt, the search prompt, to query movies. And then also, if ChatGPT wants, it can provide the rank for the movie from 1 to 10. And then if the user clarifies any specific movie category or genre, these are the list of the supported genres by the application. Then these are the response codes, HTTP response codes. If the response was successful from our application backend that is on Heroku, then we will get to this section of the specification where we are converting this object to the movie and to the response. And this is our movie object, okay? Also, in addition to the following, you can certainly load the data. You can load the user library or the user watch list. And beyond that, what I want this agent to do something useful for us, not just to search for movies, but also if I like any movies, please add one of the movies to my catalog or remove the movies from my catalog. And for that, we have this delete endpoint in the specification, and we have this put, HTTP put method documented in the specification for the user library. Makes sense? So what we do now, we just copy this. We go to the schema we provided here, and you will see that, yeah, ChatGPT recognized. So at least everything is good from the syntax standpoint. The specification was correct. These are the methods that are supported. And then you need to authenticate. You can do this without authentication, but at least I did some bare minimum. You remember that we use this API key, and this is our custom X API key. The value, we use this value many times, but sorry, I have very short memory. Let me find it here in the documentation. Yeah, so that's our key. This key is going to be passed by the ChatGPT with every request to our service. So it looks like we configured this action. And right now, let's do this, let's test it. Here I will highlight the last method that was executed and recorded by the Heroku logs. Now I want to test the movie search. Let's do the test. Yeah, like sometimes I'm getting this. It's not, I started getting this exception from time to time, but generally this is something related to my account. You should not see this exception at all. During the first execution, I will say allow, always allow. And here you can see that, yeah, it connected to my application backend, search for the movies. And all this information was retrieved from my Postgres instance, from YugaByDB that runs here also in the cloud. Okay, so that works. If you jump back to the logs, you remember I highlighted this previously last executed method, and right now that was the method that is executed by ChatGPT LLM. Hero coded this access to the APIs in the logs. Wonderful. Certainly you can check other methods, like you can load the user library, and this user library, okay, yeah, I need to regenerate. This is some of the problems with my OpenAI API accounts. But once you regenerate, again, it will talk to my application on Heroku, and it's printing right now my movies catalog, the user's catalog. We have Krampus, Star Trek, Titanic, and Lucy. We can easily check it. If we go to our books, you can see this call. And when you search for the movies for the current user, you will see that, yeah, the same movies, Krampus, Titanic, Star Trek, and Lucy. Wonderful. So generally, right now, ChatGPT have access to our application, to our movie recommendation service. And we are ready to move forward and finish the creation of this agent. The name, let's do this movie boss, why not? And generally then you can provide this description, you can spend some time creating those instructions. But you know what? The creators of this marketplace, they knew that we humans are very lazy. That's why they created a special plugin that helps you to fill in these instructions. So instead of configuring this explicitly, you can click this create button and you will start talking to the GPT builder plugin. And again, I'm lazy. I will go to this prompt. I created this prompt. What this prompt does, let me copy and paste, and I will ask ChatGPT to handle this prompt. What it says, yeah, this plugin is going to be world famous movie critic who can easily come up with movies, and you are going to use the provided action, right? The action that we have just configured to draw information from my third-party service. Additionally, you can assist users in viewing their movie catalog and updating it by adding and removing movies, etc., etc. And generally, you can see that my English is not perfect. I don't speak English natively, but nevertheless, the purpose of this GPT builder is to make sense of what I'm telling, and then it will be providing much better recommendation. So it said that, yeah, he got it, and it's going to be movie boss, and he also provided some avatar, some picture. Now we can actually also say, I don't the picture. Let's show some real human boss that stays near a theater. Okay, a lot of typos, but nevertheless, it will make sense of it. Now it will regenerate my profile picture, and then we will start testing out plugin. And how it generates it actually uses the DALL-E model. So now I provided this instruction, and then the GPT builder certainly adjusted those instructions, and it talked to the DALL-E model, and that model generated this picture. Yeah, I like it. Please save the settings. Ready to launch the plugin. The final update of our GPT, all set. And now if we go to the configure button, wonderful. So here is you can find the description and more clear and concise instructions. Yeah, it said that famous critic used their provided API. And what's cool is that you don't need to explain one more time in this instruction to the ChatGPT what those APIs are supposed to do, because everything is documented in your action specification. And then also some conversation starters. Excellent. So we're ready, right? Once you're ready, you can launch it. You can just launch it and use it by your own. You can publish it on the GPT store. I will just launch it, and everyone who has the link will be able to use it. But yeah, come on. I forgot to add the privacy policy. Let's go to the actions. That's my action. And somewhere down below, yeah, we have this privacy policy. How about this one? Oracle privacy policy. Let Oracle be responsible for this plugin. Hopefully everything is going to be all right. I copy this Oracle privacy policy. Let me save it. Let me create it. Yeah, that was all right. We are launching this plugin right now, and Oracle is in charge for every privacy violations. Okay, let's view this plugin. It's up and running. And before we start testing, let's highlight the last method that was executed from the application. Okay, so how about some of their application starters? Okay, suggest a movie for date night. Why not? Waiting. And then it starts this action, and I will allow all the actions to my third-party service. It connects, and it said that, yeah, for your date night, you have this miracle, the rain. Okay, what else? Dracula. Oh, Dracula. You know what? I read the book. I truly adored that book. And nice. I love Dracula. Could you please add it to my watch list? So generally, I'm asking this as human, and we'll see what's happening. Yes, it allows me to, I will confirm this action. And what's happening right now? Stop talking to me. What's happening? Yeah, looks like there was some glitch. Hopefully it will auto-correct itself. Something is happening on OpenAI. So now I'm at the mercy of ChatGPT. If we check the logs, yeah, it looks like user library, key violation constraint, Apache. Okay, I think that this time duplicate key violates the constraint. Okay, try to add this movie 2 times. What's happening? Yeah, I have already this Dracula. Looks like that eventually it successfully connected and it added this to my movie catalog, but then for some reason it decided to execute this action one more time. Yeah, this looks like a glitch. Let's try to stop it. Stop it. Okay, got it. Next, all right, it looks like it worked, but next, show me my current watch list. Okay, that's the Dracula that it successfully edited. Then for some reason I decided to edit second time, but my database, I had some integrity checks. It didn't allow to add the same movie twice to the catalog. And then I have Krampus, Star Trek, and Lucy. And then, okay. And I said that, I imagine that I've already watched Lucy. Listen, thanks. But I've already watched, you can say the Lucy, you can say the last movie. Please remove it from my catalog. Let's see if it's gonna work. I'm just talking to this agent as a human to human. Okay, looks like it's trying to do something. So I said that the last movie, the Lucy, and then it needs to take the information, the ID of this movie, and pass it to my, yeah, it said that it successfully removed it. Let's check with the logs. The latest logs, yes, I can see this delete operation, and that turns out to be the ID of the movie. What if I execute this request one more time? Right, I no longer have Lucy on my watch list. And finally, show me my watch list one more time. Excellent. Congratulations, we have successfully created a plugin for the OpenAI marketplace from scratch. And now this plugin can talk to our application backend, and that application backend uses the Spring AI framework to interact with our PostgreSQL database that stores some data that is unique to our business, that is unique to our service. And the last question that I need to address, and it doesn't involve any coding or configuration step. This question is related to monetization. Where is the money, my friends, you might ask? And To be honest, I don't have any successful business story to share, but my purpose, the purpose of this presentation, of this video, was to show you that it's extremely simple to use LLMs, to use the AI to create something that can bring an additional revenue stream for you or for your company. It's not a rocket science. And once you understand that this is extremely straightforward, then my second goal for this presentation was to inspire you, because you work for different companies that do something useful. You might be some expert, you might have some special skills. And by looking at how this can be created from start to finish, you can have a very interesting and appealing business idea. And you will be able to create one of those plugins that will be doing something useful, that will be used by millions and millions of users on the OpenAI marketplace, and then it will bring you extra money, extra revenue. Have fun building generative AI applications, and I wish you luck in creating a plugin for the marketplace that will make you famous, successful. So stay tuned for the next videos and keep mastering databases, my friends.